9.6 today, we're going to look at solving rational equations. So again, rational means fractions. So these are going to be equations that have fractions in them. Our first step is going to be to multiply the entire equation, both sides, by the least common denominator. We are allowed to multiply equations by anything we want as long as we do it to both sides, do it to every single part. So we're going to multiply by the least common denominator, and that will eliminate all of the fractions. So then after that, we'll have some sort of an equation to solve. It might be linear, or it might be quadratic, but we'll have an equation to solve that no longer has fractions in it. And then it's going to be important that when we complete the solving and we get to what we believe is a solution, that we check to make sure that it is not extraneous. So remember, extraneous solutions are answers that can show up even if you do everything right, that still just don't work out for one reason or another. In a fraction equation, what might cause us a problem? Dividing by 0. So what we're going to do is check and make sure that the answer that we get does not cause us to divide by 0. If it does, that means it doesn't actually work. And if that was the only answer we got, we'd say there's no solution then. Or if we got more than one answer, maybe one of the other ones still works. But we want to make sure that our answer does not cause us to divide by 0, because it's a big problem in math. So our first step is to multiply the entire equation by the least common denominator. So what's the least common denominator going to be here? 2x. When we multiply 4 over x by 2x, and that's like 2x over 1, the x's would cancel. So that would leave the 4 times the 2, which would give us 8. When we multiply the next term, the 2's would cancel, leaving the 5 times the x. And when we multiply the last fraction, the x's would cancel, leaving negative 22. Question?
The answer, like 11 over x, if the x was a group, like x plus 3, would you have to include that in your lowest common denominator?
Yep. So groups of additions like an x plus 3 are different than a plain x or a plain number.
I just didn't know if you included everything on
Yep, everything on both sides, because we're trying to clear out all of the fractions. Yep. So once we've multiplied by our least common denominator, we are going to be down to a linear or a quadratic equation, and then we can solve normally the way we've done before. So this is a linear, so what do I do next to solve?
Minus 8.
Subtract 8 on both sides. You get 5x is negative 30. And divide by 5 gives me x is negative 6. Before I really should box that in, I better check it and make sure that it does not cause me to divide by 0. So if I plug in negative 6 into the problem, will it cause me to divide by 0? No. So that's really an okay answer. But you should check that before you put a box around it. If it did cause me to divide by 0, since that's the only answer I got, there would be no solution to this question. Questions? Go ahead and do the next one. Okay, so our least common denominator here is going to be 2x. We can think of that as being 2x over 1. When we multiply the first fraction, the x's would cancel, leaving the 6. Multiply the next fraction, the 2's would cancel, leaving 1x. And the last one, the x's would cancel, leaving 2 and 12 is 24. Subtract 6 from both sides. And divide by that negative 1. Gives x is negative 18. And before we put a box around it saying it's our answer, we want to confirm that it does not make us divide by 0. But if I plug that back into the problem, it will not make me divide by 0. So that's a good answer. We could also double check that it actually works. It's often a good idea to check your answer and make sure that it's right. So we could plug that in and then confirm that this is actually true by getting some common denominators, which would be 18. So that's going to change that 1/2 to 9/18. And that does add up. A negative 3 and negative 9 would make negative 12. So we can make sure our answer is actually right if we want to as well by trying it out and making sure that it gives a true equation. But we at least need to confirm that it does not make us divide by 0. Questions? Yes.
Do we have a problem that it does? We don't know what to do. We can fix it.
If it does make us divide by 0, yes, we will have an example of that. In this equation, what is our least common denominator going to be? X minus 2. It's the only denominator that's there, so that'll be our least common denominator. Yeah. Yeah, since this is like 7 over 1. Yep, if that was any other number, but a 1 doesn't really make a difference. As we distribute that through, the x minus 2's would cancel in the first fraction, leaving just the top of 5x. We do need to multiply the 7 as well. A lot of students leave that out. That equal sign needs to keep the balance. So we're going to have 7 times x minus 2.
Can we just write 7x minus 14?
Yes, if you want to just go ahead and distribute from there, you can. You will need to distribute at some point. And then the last one, the x minus 2's will cancel, leaving the 10 times 1, or just 10. Questions on that? So then our next step is distributing, and if you just want to go ahead and do that on the previous step, that's fine, if you can keep track of that all at once. Then combining up the like terms, we get 7x minus 4 over on the right-hand side. Subtracting 7x, you get negative 2x equals negative 4. So that gives me that x should equal 2. If we go back to the original problem and plug that in, we're going to end up with a problem. If x is 2 and our denominator is x minus 2, 2 minus 2 is 0. And dividing by 0 is a big, big problem. So since that was our only answer and it doesn't actually work, that means there is no answer that will work in this problem. So we were just saying there's no solution. There's no value that we could plug in for x that would make this equation be true. Questions? Go ahead and try the next one. What's our least common denominator? X plus 1. So as we distribute that through to the first fraction, the denominator cancels, leaving just the numerator of 5x. We need to multiply the 4 as well. Distributing it through will give 4x plus 4. Multiplying that last fraction, the denominator will cancel, leaving just the numerator of minus 5. Combining like terms, I get 4x minus 1 on the right, and subtracting the 4x, I get x is negative 1. But if I plug that in, if x is negative 1, the denominator says negative 1 plus 1, which is 0, and that is a problem. So we have no solution. Questions? We have not had to do it yet, but what should we do first when looking for a least common denominator when it is possible to do so? Factor. So don't forget to factor before looking for least common denominators. So the second denominator here can be factored as what? X minus 1 and x plus 1. That's our difference of squares. X times x would be x squared. 1 and negative 1 would multiply to negative 1 and add to disappear. So now we're done with the old denominator. We'll just work with its factored form. So So then once we have factored, we can now find our least common denominator. Cancel it out. So when we multiply the first part by that denominator, the x plus 1 will cancel, which will leave with 4x plus 1 and the x minus 1. Make sure you group up that 4x plus 1 because we will need to FOIL distribute that through, not just distribute the 1. The second one, everything on the bottom matches to cancel, so we're left with just the top of 12. And don't forget to multiply by a constant, even if it's not a fraction. We still need to multiply by it, and just nothing cancels. So I get 3 times x plus 1 times x minus 1. Questions on that? So now we have some FOILing and distributing to do. So I'm going to get 4x squared minus 4x plus 1x minus 1. When you have two groups and a constant in front, multiply your two groups together first. So 4 will distribute that. We ended up with some x squared terms, which means this is what type of an equation? To solve a quadratic, we want everything on one side. So I'm going to subtract the 3x squared over, leaving x squared. I'm going to combine those two x terms together to give me negative 3x. And I'm going to subtract 12 from both sides and add 3 on both sides, so there's nothing left over on the right. And that turns into a minus 10. I'm going to get everything on one side for a quadratic equation. Then we can solve by factoring. What multiplies to negative 10 that adds to negative 3? Negative 5 and positive 2. We'll multiply to make negative 10 and add to make negative 3. So what does that mean x is? 5 and negative 2. Double check. If I plug in a 5 to the original problem, I'd have 6 for one denominator. The other denominator would give 24, so that's fine. If I plug in a negative 2, I would get negative 1, and the other denominator would give 3, so that's fine. So we end up with both solutions being good solutions. So you can have one solution, you can have two solutions, or you can have no solutions. It's important that you always check all of them.
So is the highest power of x that we're going to be working with today is just quadratic form?
Yes, we're only going to work with x squareds. Because we never learned this year how to solve a higher power of x equation by hand except for very specific types. So. We'll do this next example together as well. First, we want to factor when possible. So how does x squared minus 4 factor? Close.
The other way around. Never mind.
What do I multiply to get negative 4?
X plus 2x minus 2.
X plus 2 and x minus 2. So then what's our least common denominator going to be? X plus 2 and x minus 2 will cover everything that shows up in any of the denominators. So we multiply the first fraction. The x minus 2's would go, leaving the numerator and the x plus 2. In the next fraction, both will cancel with the denominator, leaving just the numerator of 6. Don't forget to multiply the 1, even though it's not a fraction, and nothing cancels. So we have each part present there. Questions so far? Then we need to do our distributing. So 3x squared plus 6x minus 2x minus 4. And when we multiply x plus 2 and x minus 2, we should get back to the x squared minus 4 that we had started with. Then if that was anything other than a 1 in front of there, we would need to distribute that through, but multiplying by 1 doesn't change it. This became quadratic, so we're going to move everything to one side. Subtract x squared. Combine my x's. I move the constants as well, subtracting 6 and adding 4, which gives minus 6. What do you notice about all the numbers in the problem? They're all divisible by 2, so we're going to do that. Divide them all by 2. That makes our values smaller and easier to work with for factoring. So then what multiplies to make negative 3? That adds to make positive 2. Positive 3 and negative 1 will multiply to give negative 3 and add to give a positive 2. So that means we then have x values of negative 3 and 1. We would want to double check those, going back to the very starting equation. Plugging in a negative 3 would give me negative 5 for one denominator and a positive 5 for the other one, so that's fine. Plugging in a 1 would give me a negative 1 and a negative 3, so that's fine. So those answers are both good. As long as they don't make us divide by 0, they are good solutions. Questions? This method of multiplying an equation that has fractions by the least common denominator will always work for any type of equation that has the fractions in it. We can always multiply by the least common denominator, it'll wipe out all the denominators, and then we can go from there. There's one special type of a fraction equation, though, which is called a proportion. A proportion is a single fraction equals a single fraction. And in those, we can cross multiply. So this didn't work on the previous question because we had that extra plus 1. So it's not a fraction equals a fraction. It's a fraction equals a fraction and more stuff. Okay, but if you just have one fraction, then you can cross multiply. The reason why it says we love proportions is when I did my student teaching, which was like a lifetime ago, one of the things that my prep learning still do that as a joke. I don't draw hearts around all my problems here, but I do draw an X in the middle just to show me what I'm multiplying. So when we cross multiply, we're multiplying those diagonals together. So on one diagonal, I get 1 times x squared minus x, and on the other diagonal, I get 2 times x minus 1. Distribute through. And this became a quadratic equation. So I'm going to get everything on one side. Which gives me x squared minus 3x plus 2 equals 0. And what multiplies to make positive 2 that adds to make negative 3? Negative 1 and negative 2. So I get solutions then of 1 and 2. Are they both good?
No.
Which one is not?
1.
The 1 causes us a problem. If we plug in a 1, we would end up dividing by 0. So that one is no good, but 2 is okay. So 2 would still be a solution. So we take each value and plug it in, making sure that we don't divide by 0. So we've seen all different possibilities. It's possible that we could have no solutions, one solution, two solutions that are both good, two solutions where one is good and one is not good. So it's important that you always check the solutions.
Why can't you just find the LCD?
You could still solve this problem by multiplying by the least common denominator.
Wait, I did that and I got it wrong. 'Cause for
You made another mistake somewhere else then. It would work to multiply by the least common denominator. You would need to make sure to factor. So we'd have to factor because one of those denominators is factorable from the start. But multiplying by the least common denominator will always work. That's a general method that works every time. But when it's a proportion, this is kind of a shortcut.
Oh wait, so for the first one it'd be like x times x minus 1, right?
Mm-hmm.
And then it'd just be 2 equals x minus 1, right? Or x.
Got it? Okay. So that is not a good thing. So it's just 3 that ends up working out for us. For your homework, a hint on number 45, simplify first. Okay? It is a proportion problem, so you can solve by cross multiplying, but you cross multiply it as it is, and we'll end up with a cubic equation. So before cross multiplying, simplify. When I say simplify, I mean factor and cancel out factors that match. If you do that, it will be an easier problem to solve.